The Rigol DSA 815 spectrum analyzer provides a number of different kinds of detectors to help isolate and examine different signals. Standard types like positive, negative, average, and also a few specialized detector types like quasi-peak are available. Users should select an appropriate detector according to the actual application in order to ensure the accuracy of their measurements. The signal trace displayed on the screen consists of a limited number of points. Each step in a frequency scan collects a bin of data. Each point displayed denotes a value selected from the data collection at each step in the scan within the defined frequency sweep. The selected detector type determines how each bin is analyzed and which data point is selected for display. Under the bandwidth detector menu, we can see that the analyzer provides 7 kinds of detectors: positive, negative, sample, normal, RMS average, video average, and the optional quasi-peak. The positive detector is widely used in basic applications. For continuous wave or sine wave signals, it can capture the signal accurately with minimal error. Let's look at an example. When performing a scan over a large frequency span and large resolution bandwidth setting, each frequency step or bin has a large frequency span. A positive detector setting will find the peak value within the frequency span. Now input a sine sweep signal with 50 MHz start frequency, 55 MHz stop frequency, and 10-second sweep time. Press the preset key and the analyzer will use the positive detector as a default. Press the peak button and we can see that the screen always displays the signal at 50 MHz. Now change the detector to sample and note that the signal cannot be captured and displayed stably. The sample detector is a supplement of the positive detector and can be used to measure noise and noise-like signals. For a trace point, the sample detector selects a point randomly in the corresponding frequency bin. The sample detector is ideal for viewing random noise signals. As we know, the displayed average noise level specification reflects the noise level of an analyzer. To measure this specification, let's disconnect the input, press the preset key, select the sample detector, set the center frequency as 53 MHz, set the span as 1 kHz, adjust the reference level to center the trace, set the attenuator to 0 dB, enable the preamplifier, set the RBW to 100 Hz, set the VBW to 10 Hz. Now we can see that the noise level is quite close to the typical specification. The normal detector has both the advantages of positive and sample detectors. It can be used to measure sine signals and the noise level in specified frequency bands. For example, if we input a 50 MHz sine signal, press preset, and select the normal detector, we can see both the sine signal and the noise. The RMS averaging detector is often used in power measurements, especially when measuring channel power. We will cover this measurement in more detail in a future video. Voltage and quasi-peak detectors are often used in EMI testing. The voltage detector can be used to measure the narrowband signal that is contained in a wideband pulse signal. A quasi-peak detector responds very much like a capacitive network, charging and discharging at a known rate. This detector is designed to standardize the response of the spectrum analyzer and return repeatable amplitude measurements given a repetitive pulsed signal. Finally, there is a negative detector which can be used to distinguish sine signals from pulse signals. This concludes our introduction to spectrum analyzer detectors. Here are the key points. Positive detectors are ideal for signals that are similar to CW or continuous wave and sine waves. The sample detector is ideal for noise measurements. The normal detector should be used when performing sine and noise measurements concurrently. The RMS detector is ideal for power measurements. Positive, voltage, and quasi-peak detectors are primarily used in EMI testing. Thank you.